Hello guys, so here we are to another question, the question number 2 of the contest 208. It was a tough question in the sense that we had this complicated um, question description. After I found the description of the first question, I believe that they would spare us some time here and come up with something easier to understand, but that didn't happen. Good for us. So the first step was to understand what they want here. So I was introduced to a number of things here. One of them was what is a gondola, and a gondola, well, this is like the wheel of London, okay, where you can go around and around. So, and these gondolas is where people sits in. Um, or sits at. I'm sorry for my bad English. So the goal here is to find the minimum number of rotations to maximize profit. So what do we have to accomplish here is we have maximum profit if the capacity of the gondolas is filled every time. So every time we rotate our wheel, if we have our gondolas filled, we will definitely have um, maximum profit. What can happen? What can happen is that you don't have people enough to fulfill the gondolas, but you want to always fill the gondolas with the maximum number of people possible. And then there are a number of restrictions that you have to take into account. One of them is that you are forced to rotate the the wheel, okay. You receive a number of customers, okay, and the customers arrive before the wheel is going to spin, and at every time that a customer arrives, the wheel spins, okay, and this is something that is mandatory and you have to do it, okay. You cannot wait like for the customers to get to four to fulfill and then rotate. That's not possible. You have to rotate at every time a customer arrives. So this is pretty much the scenario, okay. We have to rotate the gondolas every time, and before we rotate, the clients or new clients arrive as per the array. After this, there are clients that can be remaining, and we have to rotate the wheel until we get what we until we have no more clients to serve, okay. um, and another thing that is told in here is that you can stop before including before serving all the customers. Okay, so my solution is not perfect, okay. My solution is a greedy one, is a greedy solution, and it is not perfect. It is not code optimized and all that stuff, because I have wasted already a lot of time with this question with another approach because I misunderstood the question. So I had to implement it twice, and so my solution is divided into two steps, just as I explained. So I do mandatory rotation, which is the rotations that are controlled by the input array, okay. Every time a client arrives, I rotate, okay. Every time a client arrives, rotate. Uh, and what this means, client of size 10, we rotate and we can only take 4. 6 are waiting. Okay, then 9 clients arrive next iteration. We rotate again, we have to rotate, and from the 9 plus 6, from the 9 plus 6 we take 4. Okay, and 9 plus 6 is 15, so we take 4, it stays 11. You see how it works, and then we have to do this math that is just like here, and I will not explain this. This is just math. So next, after we do mandatory rotation, we will calculate the remaining clients, the remaining customers. So that's about it. Okay, guys. So what do we have here? Um, we have some variables here, okay, to do the math, and we have this very important variable, which is the waiting clients. So each iteration, I accumulate, I calculate the waiting clients, and then what is this? It's not needed. In each iteration, we accumulate the. I'm sorry, I have some code here that is not necessary. Okay, we have this variable that is very important, and it accumulates the waiting customers. So in the first iteration, we put all the customers to wait, and then what we do the mandatory rotation. And if we have less than 4 people, 4 clients, we onboard them all. Okay, so the wait stays 0. If we have more than 4 clients waiting, we remove from the waiting list, and we onboard the 4 elements. We increase the number of rotation, we apply the provided formula, and we see if the profit is bigger or not. Okay. Yeah, that's it. Looks like I have a couple of variables here that are not being used. It's remainings of my from my development. Sorry for that, but it's okay. So you get the picture for the mandatory rotation. So the same applies when we finish the mandatory rotations, but still have clients remaining. In this case, we can calculate them. Okay, we can calculate them in the same manner. If we have more than 4 clients waiting, we remove the clients from the waiting list, we onboard them, we increase the rotation, and we apply the mathematical formula, and then we check if it is possible. Okay, if it is better, we update, else we don't update. And then finally, if the remaining is below 4, we do this exact code. Okay, it is about the same. Okay, um, it is about the same, this code. So yeah, this is not code efficiency. Is a lot of code repeated here. It could be improved, but I was in a hurry and I already had spent a lot of energy. Then if the profit, if the max profit is bigger than zero, or equal to zero, and okay, in the end it was needed. I'm sorry, I said that this variable was not needed. I'm sorry. I'm sorry. This variable here, it is a detail, but it is important detail, because I start with the max profit with the value 0, and I need to identify if I have updated it. That's why I use this variable here. And then if the max profit is bigger or equal to 0, I um, and I have updated it. I return the max profit, else I return -1. This is just a detail. I think that the main logic is what I have shown you, and that was how I have solved it. I bet there are better solutions out there to do this problem, but this was how I have solved it, and it was a challenging one, both because of the description, which was not clear, and in the end the greedy solution, in which I had a couple of tries to have it working perfectly. So that was it, guys. Oh, mistake. So dumb. This was ridiculous. So here you have it, guys. Okay, let's go to the next question.